Okay, so we're gonna finish up chapter 1, which is 1.7 today. On Monday, or sorry, Wednesday this week, we will start reviewing chapter 1. Oh, didn't we do that part? Chapter 1 homework due. And then Monday next Monday, chapter 1 homework is due, and that is our chapter 1 test. How did I forget that? So Wednesday we review. Monday's the test. All the homework is due for chapter 1. Please follow directions on the assignment sheet. Next Wednesday we start with chapter 2. This problem right here. We're going to do this one first. Get it out of the way so we'll focus on that one. So 1.6, the operations on functions. I was very clear about what you needed to do. Step 1, rewrite. What does this mean? So F circle G of 1, rewrite. The outer function is F of, inside that we're going to plug in G of, what we're going to plug into G is 1. So the first thing I have to see from you is F of G of 1, rewritten. So from circle notation to function notation, parentheses. You have to show that. Rewrite it. Step 2. Substitute. So from outside to inside, I want to figure out what F of this is. Well, I can't do F of this until I know what this is. Order of operations, you got to do what's in the parentheses first anyway. So you've got to start inside here. You got to start with what G of 1 equals. Substitute. Well, G of 1. Now, in a picture, they're just ordered pairs. That's all it is, ordered pairs. On the G function, when we plug in 1, the y coordinate is 0 on the G function. G of 1 is 0 because that's where the point is located. So G of 1 is 0. Substitute. The third step is simplify, but we don't have any functions that we're actually plugging things into. So simplify really doesn't come into play here. But when you actually are given like f of x is 5x squared minus 2x plus 3, then you plug it in and simplify. So now this is a 0. It's f of 0. So now you're looking at the f function, the ordered pair on f where x is 0. Well, x is 0 right there. And the y coordinate is a 2. You plug 0 into the f function, you get 2. So G circle F, or sorry, F circle G of 1 is 2. Okay. If you bother looking at the review sheet, you're looking at stuff right here, number 24. I know that it's kind of hard to see with my stuff. F circle G of -5, rewrite it so you can simplify. You're finding ordered pairs based on the ordered pairs. Yes, ordered pairs. Okay. There's F and there's G. Now, If you look at the actual problem 24 on your review sheet, that's a horrible, horrible picture because look at all of the points that are like so jammed. We have fractions that can. I labeled them with the actual order pairs, so it looks better, and you're not guessing. And we're going to use that as an example for chapter 7. Chapter 7 is going to look like that. So I've labeled it order pairs, and that's what it looks like on the review. Okay. Yeah. Okay. When we did this section before, I think it was fine. Let me just refresh my memory because I'm sure you guys remember like yesterday. I can't remember yesterday. I can remember yesterday, but it was 20 years ago. No. So we're supposed to take number 19. Here's the picture of F, and then you want to graph F of X plus 2, F of X plus 2. So we did a table with ordered pairs. Here's all the ordered pairs from function F right here on the table on the left. And then what will the ordered pairs be for the brand new function? Write down the ordered pairs and then plot your new ordered pairs and graph the graph. And then what is it going to look like if it's negative F of X? Well, take these ordered pairs right here, or you wrote them out for you, and then do this to it, whatever negative F of X means. Okay, one little bit at a time, seeing how the transformations work. So that's what's going to happen here. First thing, I want these ordered pairs. So from left to right, F of X is -2 and a +4, a 0 and a 3, a 1 and a 0, a 3 and a -1. And then G of X is going to be -2 times F of that X, we have +2, wonder what that's going to mean, and then a +1. Hey, what does A do? If A is negative, it's gonna reflect it, or upside down. It's gonna reflect it across the x-axis. If you had a positive y, it's now a negative y. It goes to negative y, it's now a positive y. It's gonna change the sign of your y coordinate. It's gonna change the sign. And since over here, what does A actually equal? -2. Not only is it going to flip it, positive becomes negative, negative becomes positive, you double it, multiply by 2. So stretch it. Okay. H is the horizontal shift. H is going to move it left and right. If there is an H, it has to be in the parentheses with the X. So if it's not inside of parentheses with your X, you don't have an H. The negative is already there. So when you take out the horizontal shift, you're going to do the opposite direction. If I see -2, if I see X -2, then H is a +2, and you're going to move it to the right 2. Everything's going to get shifted to the right 2. If you had an X +2, then the horizontal shift is a -2, and you're going to shift to the left 2. So in this one, we see an X +2. So the H is a what? A -2. We're shifting everything. Everything in this picture is going to shift to the left 2 units. Everybody's going to go to the left. And then K is the vertical shift. K is a plus in front of it, so you keep the sign. So K is going to add or subtract something to the old Y values. It's going to change your Y coordinate. That's the vertical shift. So over here, what's this K value? +1. So we're going to add 1 to all the old Y values. After you double it with a -2. I'm going to make this a little bit white so you can see how it transforms. Okay. Let's just focus on the X's, just the X's. I only know what we're going to get if I plug in a -2. That's the only thing I know. I can't take F of anybody else except a -2, a 0, a 1, and a 3. So when I see this +2, I'm not going to take -2 + 2 and say this is 0. Because when I get down to here, if I keep that trend going and I say this new X is 3 + 5, with 3 + 2, it's 5. 3 and then +2, if I do that. So I say I'm going to plug in 5. Well, I need a Y that comes out if I plug in a 5. I can copy it. You see what I mean? So you do the opposite direction. If that's -2, then we're going to take away 2 because it's a shift this way. The X that we're going to plot is going to be at -4. And then think about it. If I plug in -4 + 2, what am I going to actually be plugging in into the function? That's a what? -2. And I have an answer when I plug in -2. I have a Y coordinate for that. Over here, this one would be plug in 3, and then you take away 2. 3 take away 2, and I get a 1. So that's the X coordinate I'm going to use when I make that graph. I'm going to start to use 1. So if I plug in 1 for X, what's 1 plus 2? I get f of 3, which I've got a y coordinate for that. So because h is -2, these old x's are all -2 from the original x's. So that's -2, h is -2 minus 2. 0, you're going to take away 2, I get -2 there. 1, I'm going to take away 2, I get -1 there. This x is a 3, move it to the left, 2 units, 3, take away 2, this x is going to be a 1. So that's all your new x's. All the old x's move 2 to the left. And if you want to think about it on your picture, if this went 2 to the left, it would be a -4. If this went 2 to the left, it would be a -2. 2 to the left, that would be a -1. 2 to the left, that would be a 1. Okay. But what we're looking for is the order pairs. Because there's a lot going on. So now the y's. What's happening to the y's? Well, remember, f of x is just the y coordinate. The value of the function is the y coordinate. Okay. So the y coordinate is a 4, a 3, a 0, and a -1. Here's what's happening to the y coordinate. You're multiplying by -2. You're taking the old f of whatever, the old value of the function, multiplied by -2, and then you're going to add 1. It's -2 times the y value, and then plus 1. So the old y value is 4. So it's going to be -2 times that 4. And then you're going to add 1. So -2 times 4 is -8. -8 plus 1 is equal to -7. So this ordered pair is going to be a -4, -7. -4, -7. They equal it. This old y value is a 3. So I'm going to multiply the y value times -2. So it's -2 times that 3. And then we add 1. So that's -6 plus 1, which is -5. So the ordered pair here is -2, -5. -2, -5. Label it. The old y value is 0. So the new y value is -2 times the old y value, -2 times the 0, and then plus 1. So 0 plus 1. So the new ordered pair is -1, 1. At -1, we get 1. And for the last point, the old y value is -1. So we take this old y value, multiply it times -2 times that -1, and then we add 1. -2 times -1 is +2 plus 1. So the new one is at 1, 3. Right? So the new graph is this. Let's compare. This point right here got shifted 2 to the left. So instead of -2, it's over here at -4. Then you took the y value and you took that 4 and we multiplied by -2. So now we have -8. It was 2 times the f of x plus 2 and then plus 1, -2. So this becomes -2, -8 when you flip it, but then you're supposed to shift it up 1, so it shifted up to -2, -7. So it used to be at -2, 4, it shifted 2 to the left, it got flipped down to -4, -8, and then shifted up 1. Zero 3 got shifted 2 to the left. That 3 got multiplied by -2. It's down here at -6. So we're at -2, -6. And then we shifted up 1. It ended up at -2, -5. There. This 0, 1 got shifted to the left 2. So we're at -1. It got multiplied by -2. 0 times -2 is still here, but then we add 1, so it got shifted up 1. So it ended up right here, which is at -1, 1. And then this one got shifted to the left, so now it's at 1. Multiply this times -2. -2 times -1 is now up here at +2. And then it got shifted up 1 more to 1, 3. By following the recipe. What are you doing to the x's? Because that's a -2. Take these x's and subtract 2 from all the old x's. Those are your new x's. What are you doing to the y values? Take the old y values, the function value, multiply by -2 and add 1. So 4 multiplied by -2, I get -8. And then we add 1, becomes -7. So now I have an ordered pair. Plot the ordered pair, do it again, do it again, do it again. Multiply and add. If you don't practice it, you won't be ready for it. Okay. In mathematics, or as the British like to call it, in maths. Their plural for mathematics is maths. They study maths. When we first teach you how to do something, then we come along and teach you how to undo it. Teach you how to add, then we teach you how to subtract. Teach you how to multiply, then we teach you how to divide. Teach you how to square a number, teach you how to take square root of a number. Teach you how to take the sine of an angle, then we have to do inverse sine of an angle. Or inverse sine of a ratio to get the angle. And teach how to do an exponential function, then here comes a logarithm. How do we undo that? Every time we learn how to do one thing, we have to learn how to undo it. Teach how to take a derivative, teach how to do an indefinite integral, an anti-derivative. Go left, we got to go right. Okay, and it's just undoing what just happened, which is solving equations. You got to be able to undo something that just happened, inverse operation. So every set of ordered pairs is a what? All sets of ordered pairs are your cousins, your aunts and uncles, your relations. All sets of ordered pairs are relations. Special sets, if x doesn't repeat, is called a function. A special set of ordered pairs if x does not repeat for every x, you only one y, is called a function. Not every function has an inverse to it. Okay? First of all, the inverse functions are this simple. All you do is switch the ordered pairs. You just switch the ordered pairs. You switch the domain and range. You switch the x and y. So if you have function f, is this set of ordered pairs? Let's go with negative, to just make it up numbers, negative 2, 5. Negative 1, positive 8. Let's go with negative 19, negative 20. Five thirds, 12 over 7. Four. That's 5 ordered pairs. It's a function. Okay. We would say this function f is equal to this set of ordered pairs. And again, I'm not going to make you do the set notation, but this function f is equal to that set of ordered pairs. And I know it's a function because the x's don't repeat. Negative 2, negative 1, negative 19, a 5 thirds, and a 4. I don't have any x's that are the same. Y's can repeat if we had them. If we had repeating y's, that's fine. The inverse function. The inverse function of f of x is written as, you got to follow along with me here. That is not a negative 1. That is not a negative 1. Okay, but it's not an exponent. It looks like it, but it's not. It's a notation for inverse function. It's all about notation. This f inverse of x does not mean do not flip it, because that's not an exponent. This means the inverse of function f of x. That's all. It's the inverse of function. It has a completely special designation. If I wanted to flip over function f of x in a bracket to a negative 1 is now going to be 1 over f of x. The whole thing would have to be raised to a negative 1 power. Then you would flip it. That means that if that's a negative 1 power. So don't do what you think it is. Do what it actually is. Case in point. The trig students, some of them are struggling. On a calculator, and I tell them many times. Right here, they have their sine, cosine, and tangent buttons. And right above it is this button. They also have the sine of x is equal to, well, The cosecant of angle x is 1 over, it's the reciprocal of sine x. So they think if they press this button, they're doing cosecant. That is not the cosecant button. There is no cosecant button. This -1 is the inverse of the sine button. It's the arc sine button, technically, is its actual name. When you take the sine of an angle, the sine of 60 degrees is equal to square root of 3 over 2. So the inverse sine of square root 3 over 2 turns it back into 60 degrees. If I know the ratio, it'll tell me the angle. If I have the angle, I plug it into the sine function, it gives me the ratio. If I want cosecant of 60 degrees, then I have to punch up what is 1 divided by the sine of 60 degrees. And that would be 2 over the square root of 3. This is just a reciprocal, you just flip it. But that's what they got to get used to. That's not a cosecant button. It's not a -1. It's inverse. Context. Context. I pressed the button, that's what the calculator told me. Yeah, but that wasn't the question. Okay. Back to our regular bits. The inverse function undoes the original function. F inverse undoes F and vice versa. Function F will undo F inverse. They undo each other. Bottom line is you're just going to switch the ordered pairs. The inverse function, F inverse. This would be 5 -2. This would be 8 -1. This would be -20, -19. This one would be 12 over 7, 5 over 3. And this one, if you switch your pairs, you still get 4, 4. Here's what I mean by undoing each other. According to this notation, if you plug -2 into the function, f of -2, what comes out? What do we get? We get 5. Thank you. You plug see x coordinate, you plug -2, x goes into the function, out comes the y value. So x goes in, we get -5. The inverse is going to undo that. We would plug 5 into the inverse function, and it's going to change it back into the -2. It undoes what f did to that -2, turn it right back into the -2, right back where it came from. If I plug -19 into the function, f of -19, the answer is -20. Now, if I take that -20 and plug it into the inverse function, The answer is negative 19. It turns it back into the original x that we started with. It undoes what f did. That's the whole point. Inverse function. Switching the x and y coordinate. It switches the x and y. The domain of f, the domain of this function f, is the range of the inverse. It's the range of the inverse function. And if you look at it, that -2 is this y value, -2. That -1 in the domain is this y value in the range, -1. All of these x's are the y's in the inverse function. And the range of the f of x, the range of f of x, is the domain, switching domain range. The y value that came out, this 5, that's the range. The range is an 8, -20 is in the range, 12/7. Those y values, the range, are the domain values that we're plugging into the inverse. What goes in is what comes out here. What comes out is what goes in here. You switch the x and y's. You switch the order pairs. Inverse function, you switch the order pairs. Yeah. Every set of order pairs, these are relations. It's a set of order pairs. It's a function because the x's don't repeat. Not every function has an inverse function. Not every function is going to have an inverse function. In order to have an inverse function, it has to be 1 to 1. Must be 1 to 1. 1 to 1 means for every x, there's exactly one y, and for every y, there's exactly one x. So let me go backwards. If it's a function, x can't repeat. If it has an inverse, x and y cannot both repeat. Neither can repeat. I'm going to change one of these original function numbers. I'm going to change. Let's just change. Wait a second. Let's change this from 4,4 to 4,8. Okay. It's still a function, the original one in blue, because the x's don't repeat. It's still a function. But now it does not have an inverse. X doesn't repeat. X doesn't repeat, so it's a function. But it doesn't have an inverse because we have a y coordinate that does repeat. And the reason why it doesn't have an inverse is because when you write the inverse ordered pairs, -2, 5, so 5 negative. -1, 8, so 8 negative. Negative 20, -20, negative. 5 thirds, 12 sevenths, 12 sevenths, 5. 4, 8, this would be 8. When you write the inverse function ordered pairs, you have an x coordinate that repeats. So therefore, the only possible inverse function that you have isn't a function. Because that x, that 8 repeats. So the inverse does not exist. Okay? Not every function has an inverse. Every function has an inverse function. X and y must both be 1 to 1. X cannot repeat, y cannot repeat. Then you can have an inverse function. If function f of x and g of x, if they are inverse functions, if f of x and g of x are inverse functions of each other. If they're inverse functions of each other. Then, now, I'm going to over here on the side, see if we can make a big leap from this over to the actual generalization. If they're inverse functions of each other. If they're inverse functions of each other, if f undoes g and g undoes f, what am I supposed to get if I take f of g of 2? Give you an analogy. Inverse functions are like tying your shoes. One function ties your shoes, the other one's going to untie your shoes. It's going to undo what just happened. What would you do first? F of g of 2. What do you have to do first? The g of 2. And it's going to turn it into something. What? I don't know. I don't have a g of x on it. But it's going to turn it into something. So, basically, what? G of 2 equals sum 10. How about that? So that equals something. So then we're going to take that something, and it's going to go in here, and we're going to get f of something. If they're inverse functions, what is f of something going to be? One. Order pairs. We plug in 2, out comes something. for the order pair here for G, a 2 and a something. So then we plug in something, so that's the x coordinate. So what comes out is the x coordinate. Which was your pairs. So the bottom line is, back to this, if they're inverse function, G of 2 is going to change it into what? I don't know. But F's going to come right around and undo what just happened and change it right back into that 2 that you started. It's going to undo it. Because they're inverse functions of each other. If you have G of F of -3, what's the answer? -3. Provided, again, they're inverse functions. You're told they're inverse functions. F of -3. I want something. But then G undoes it, we're back to -3. So generally speaking, in general, if they're inverse functions of each other, then F of G of X, F of G of whatever X may be. No matter what you plug in, G changes it into something else, and then F comes right back and changes it right back into the X you started with. It undoes what just happened. It undoes it. And G of F of X. You plug X into the F function, changes it into who knows what. Then you take that answer, you plug it into G. G changes it right back to where you came from, where you started with, which was the original X. And do each other. What is F? What is F circle G of 6? What is G circle F of -5? Work over. Well, step one, you should rewrite it. So outside of F, inside that is G, and inside G, we're plugging in the number 6. So you start inside it, evaluate G of 6. Plug 6 into G. It's 1/3 of X plus 4. So this is 1/3 of 6, and then we add 4. So G of 6, on a test, I want to see all this work. I want to see this rewritten. I want to see the substitution, and then simplify. 1/3 of 6 is 2. 3 goes into 6 2 times. 2 plus 4 is 6. So G of 6 equals 6. So this becomes F, and inside that's a 6. So we plug 6 into the F function. 3 times X minus 12. 6 goes in. 3 times 6 minus 12, and we get 18 minus 12. 18 minus 12 is 6. So we took F circle G of 6, which was F of G of 6, plugged 6 into G. G turned 6, well, turned it into a 6. And then F took that 6 and turned it right back into a 6. It still stayed 6. Maybe that's a coincidence. Maybe. Maybe it only works for a 6. Let's check a -5. Bring it back. G of F of -5. So F of -5. So 3 times X, so 3 times -5. And then a minus 12. So F of -5 is equal to -15 minus 12. So F of -5 is equal to -27. So we plug in -5, we get -27. So this is now -27. So we get G of -27. So we're going to plug that into the G function. Whatever goes into G, multiply by 1/3, and then you add 4. So that's equal to 1/3 times this -27. And then we add 4. A positive times a negative is going to be a negative. What's 1/3 of 27? 9. 3 goes into 27 9 times. So -9 plus 4, which is what? -5. Remember, this was G circle F of -5, which is G of F of -5. We plug -5 into F. F changed it into -27. We plug that answer into G, and G changed it right back into -5. G undid the F function, but over here, according to this, F undoes whatever G did. Or maybe it only works for 6, and maybe it only works for a -5. Here's the deal. How do you know they are inverse functions for all possible values? There's an infinite number of numbers you'd have to try. You'll never finish. Definition. They're inverse functions if this happens. If F of G of X is just equal to X. If G of F of X is just equal to X. So if we plug in X and we end up with X, it works one way, and then you got to try the other way. So just showing that it works for a 6 and a -5, that doesn't mean they're inverse functions. That means it works for a 6 and a -5. You got lucky. You have to show that it works for every single possible number. So you got to show that it works for X. If you can show that it works for X, it works for everybody. Because you can replace X with anything. So here we go. Which this is what you're supposed to be able to do anyway. Composition of functions. You're supposed to be able to do something like what is F circle G of just an X. That's from 1.6. So first thing, rewriting. From left to right, F, and then inside F, you're plugging in G of X. Well, you got to go figure out what G of X is. G of X is that 1/3 X plus 4. That's all you know. So that's all you can work with. What I'm showing you is exactly how I hope you do it on your test. So you're going to replace this with this because that's all you have. So it becomes F of substitute. Sorry, rewrite it in this form. Substitute, and then we're going to simplify. F of 1/3 F plus 4. So we plug 1/3 X plus 4 into the F function. So we're going to replace this with a 1/3 X plus 4. So that X right there, 1/3 X plus 4. So whatever goes in 3 times, what am I going to say you better be careful with? Use parentheses. So 3 times this 1/3 X plus 4. Three times that X, which is now 1/3 X plus 4, and then minus 12. Distribute. 3 times 1/3 is 1. 3 times 1/3 X plus 3 times 4. So that's going to give us, and then a minus 12. 3 times 1/3 is just 1 times X. Plus 12 minus 12. So what do we end up with? Okay. G circle F, F circle G of X is just X. F undoes what G did. G turned it into a 1/3 X plus 4, and then F undid it, turned it right back into X. Like a magic trick. It's got to go both ways. If it only goes F undoes G, that's not enough. It has to work in both directions. G has to undo F. So now we're going to see if G circle F of X is equal to X. So we rewrite it. G of F of X is this. F of X, 3X minus 12. So we're going to replace this with 3X minus 12. Whatever goes into G, you multiply by 1/3, and then you have 4. So it's going to be 1/3 times. We're plugging in 3X minus 12. And then plus 4. It's good. You get 1/3 times 3x. Positive times a negative is going to be a negative. 1/3 times 12. And then a plus 4. What's 1/3 of 3x? You got 1 times x, and what's 1 times x? Just x. Minus 1/3 of 12 is 4. So minus 4 and then a plus 4. So x minus 4 plus 4 is just 4. Yeah. They undo each other. Into which function? This is how we graph inverse function. Don't worry about the functions that I'm plugging in right now. Just be patient with me. I'm going to graph this function. What my y sub 1. I'm going to punch in x to the 3rd plus 1. Okay. And then I'm going to show you how I can get the inverse of it. X to the 3rd. Oops. 1. I had to change the window just. So this is negative 7. This is positive 9. You'll see why in a little. Negative 2. Negative 2 cubed is negative 8. Negative 8 plus 1. This is negative 7. So right here is -2, -7. -1. -1 to the third is -1. -1 plus 1 is 0. So right here, we're at -1, 0. Plug in 0. 0 to the third is 0. 0 plus 1, we're at 1. 0, 1. 1. Plug in 1. 1 to the third is 1. 1 times 1 times 1. And then plus 1. 1 plus 1 is 2. So when we plug in 1, we get 2. And then we plug in 2. 2 to the third is 8. 8 plus 1 is 9. Plug in 2. We get way up here, we're at 2, 9. And those are the ordered pairs for this first function, y sub 1 is equal to x to the third plus 1. Inverse functions are reflections. They're reflections across the line y equals x. Inverse functions are reflections across y equals x. Here's why. Because we switch the order pair. We switch the order pair. Here's y equals x. That means every time x is 1, y is 1. When x is 2, y is 2. When x is 5, y is 5. It's this line right here. 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. It's this diagonal line that goes right like this. So this is the reflection line. When I say reflection line, think about the word reflection. Like a mirror. It's like a mirror. When you're staring at yourself in a mirror, let's say you're 2 feet in front of the mirror. Your image looks like it's standing 2 feet on the other side of the mirror. As you get closer to the mirror, your image is starting to get closer to you. If you walk towards the mirror at an angle, your image will walk towards the mirror at the same opposite angle from the other side. Whatever you're doing on this side, your image is doing the same thing, but on the opposite side. It's as if the ordered pairs were often switched. Switch these ordered pairs. -7, -2. Right here. -1, 0 is now going to be 0, -1. 0, 1 is now going to be flipped over here to 1, 0. 1, 2 is now going to be over here at 2, 1. 2, 9 is now going to be over here at 9, 2. So the inverse function is like you're approaching the mirror, your reflection is over here, so it's going to approach the mirror as well. When you walk through the mirror, if you were to walk through the mirror, your image would have to walk through the mirror to our side. You're in the mirror universe, and now they're in our universe. So now you're on this side of the mirror. So your mirror image, the image would be over here. And that's what the graph of the inverse function would look like. Let me put it in the inverse function. Here's the original function. And here comes the inverse. I didn't need the equation to graph the inverse function. I just switched order pairs. If I know one set of order pairs, I know the other one set of order pairs. I just switch X and Y. No matter what. I say you graph the inverse. If I know one set, I switch the order pair, and that's the other function, the one that undoes it. Okay? Switch the order pair. So we're going to do 15 to 18 all in the moment. It's matching. So you have numbers 15 to 18 right here. And then A through D are the potential inverse function. And that's a graph of the function with a graph of its inverse function. Okay, the inverse functions are A, B, C, and D. Pull down the screen. So let's start with 15. 15 and 16 are both lines. So their inverse functions should be lines, not curves. So you can eliminate choice A and choice D. Which one do you think is the inverse of 15? Let's make it real simple. That ordered pair right there is 0, -1. So the inverse function should have -1, 0. So C is the inverse of 15. I have an ordered pair that's just switched. 16. That right there, let's use this one, is 0, 6. So the inverse should be 6, 0. That's 6, 0, so the inverse should have 0, 6. So 16 and B are inverses of each other. And since they're the same picture, it is its own inverse. Now, 17 and 18, what's the only one that can be the inverse for 17? Okay. But again, this is 0, 1, up there is 1, 0. Matching up. And then this is what it looks like the one we just did, the X to the third. This point right here is 0, 0. So my inverse function should have 0, 0. This is the only graph that goes from 0, 0. Don't make it more difficult than it is. You just find ordered pairs that would switch. $74. Remember when I typed in the inverse function? The second equation, x minus 1 to the 1/3 power. Here's how you find an inverse function. When you actually have to come up with the inverse function itself. It is 3 steps to get the inverse function. 3 steps. Step 1. You're probably going to be given, here's f of x, find f inverse of x. Find the function f inverse of x. Well, step 1, replace f of x with y. Change that to a y. So instead of f of x equals x cubed minus plus 1, it's y equals x to the 3rd plus 1. Step 2. Switch x and y. Inverse functions switch order pairs. They switch domain and range. So that's how we get the equation, is we actually trade places. Switch the x and y. So instead of y equals x to the 3rd plus 1, it's x equals y to the 3rd plus 1. And then solve for y. That's the inverse function. Inverse of x. So to solve for y, I have to undo what's being done to y, subtract 1. I have x minus 1 equals y to the 3rd power. To undo a 3rd power, a cube, I take the cube root of both sides. The cube root of y is just y. Over here, cube root of x minus 1. So the inverse function is the cube root of x minus 1. Now, I don't have the ability to type it in with a cube root symbol. That's why I use x minus 1 to the 1/3. A 1/3 power is the same as a cube root. 3 steps. So using these pictures, we're supposed to answer the questions at the bottom. And the way you're going to answer the questions, you're going to want the order pairs. So here's my ordered pairs for f of x. I have -4, +4. I have uh, 0, 2. I have 1/2, 0. I have 1, -1. I have 3, -2. I have 4, -4. This is on f of x. Over here, I've got -5, -4. -3, -2. -2, 0. 0, 2. 1, 5/2. 2, 3. 3, 5. 4, 6. It's all about ordered pairs. We want G of 0, G inverse of 0. To get G inverse of 0, because I don't have a picture of G. Number one, I don't have a picture of G inverse. I don't have anything I can plug it into. I can't like plug substitute and simplify it. But on G of X, all I'm going to do is take the ordered pair. If this is X on the inverse, then what is it on the function? It's the Y coordinate for G. If this is what I want to plug into the inverse function, then it must be, that's the X, it must be the Y from the given function. Whatever this X is for the inverse, it's the Y coordinate of G. So over here on G, when Y is 0, X is -2. So G inverse of 0 gives us -2. Number 96, do they want inverse functions of anything? Do you see the notation for inverse? No. It's just what is G of F of -4? So what do I do first? I have to do what first? F of -4. So we look over here on the F function. When you plug in -4, the Y value is a +4. F of -4 is +4. So this is now G of 4. And now you go to the picture of G. When we plug in 4, we get 6. So G of F of -4 equals 6. G inverse circle F of 3. Okay, there's a lot going on. First of all, do they look like they're inverse functions of each other? No, they're not inverse functions of each other. We're just taking values and plugging from one to the other. First thing you should do is rewrite this. What is the outer function? What's on the outside? G inverse. G inverse, oh, what am I plugging into that? F of 3. So G inverse of whatever F of 3 equals. So we go over here, F of 3 is -2. F of 3 is equal to -2. So now this becomes G inverse of -2. I don't have the inverse ordered pairs. G inverse of -2. So I want to plug -2 into the as an X coordinate into the inverse. So where do I pick it up from? The inverse function, -2 would have to be the Y coordinate. Okay. Where does this inverse -2 come from? It's the ordered pair where the Y is -2. Now this guy, that's X. That's the domain of G. I want the Y value, this Y value. So G of -3 equals -2. So this ordered pair, -3, -2, means on the inverse, -2, -3. You might want to take an aspirin before you do this, because you start to lose track of what you're looking at. which is why you want to write it down. And you want to put right that in order of pairs and keep track of it, rewrite this. So F inverse of G inverse of 6. F inverse circle G inverse of a 6. So you rewrite it. On the outside is F inverse. Inside that is G inverse, and inside G inverse we're putting in 6. So if we're going to do G inverse first, G inverse of 6. That means on the inverse function, X is 6. So what we're going to need to figure this out, we need G of 6 because we're going to switch the order pairs. What is G of 6 equal? Oops, my bad, not G of 6. That's the X, so this is the Y. When does G equal a 6? 4. When we plug in 4, we get 6. So I want to plug 6 into the inverse function. So if I'm plugging in 6, then what comes out? What comes out is this X. This is just F inverse. And this is the 4. So that means we need F of some number equal to 4. Because up here we're plugging 4 into the inverse. This Y is this X. So on F of X, when does Y equal 4? So negative 4. So that's what this equals over here. Well, Wednesday we'll review it. If you're late, if you let me know, I'll give you your quiz. Turning on the lights. I wouldn't have marked them later had I not picked them up already. When I said, is there any more? The only reason I would have marked it late is if I already had a